Hello guys, welcome to a brand new section of this course, Tasting Functional Style in C#. We'll start off this section with an introduction to functional programming concepts and comparison between the functional and imperative approach. We would then learn the concepts of functional programming. Later, we will move on to using the mathematical approach to understand functional programming. Lastly, we would see refractory imperative code to functional code and the advantages and disadvantages of functional programming. Now we move on to the first video of this section that deals with introducing functional programming. In this video, we're going to take a look at understanding definitions, scripts, and sessions, using substitution and simplification to evaluate the expression, understanding the functions used for functional programming, forming the definition, and curing. In functional programming, we write functions without side effects the way we write in mathematics. The variable in the code function represents the value of the function parameter, and it is similar to the mathematical function. The idea is that a programmer defines the functions that contain the expression, definition, and the parameters that can be expressed by a variable in order to solve problems. After a programmer builds the function and sends the function to the computer, it's the computer's turn to do its job. In general, the role of the computer is to evaluate the expression in the function and return the result. Suppose we have the expression 3 plus 5 inside a function. The computer will definitely return 8 as the result right after it completely evaluates it. However, this is just a simple example of how the computer acts in evaluating an expression. In fact, a programmer can increase the ability of the computer by creating a complex definition and expression inside the function. Not only can the computer evaluate the simple expression, but it can also evaluate the complex calculation and expression. Let's understand definitions, scripts, and sessions. We know a calculator analyzes the expression from the functions. Let's imagine we have a calculator that has a console panel like a computer does. The difference between that and a conventional calculator is that we have to press enter instead of equal to in order to run the evaluation process of the expression. Here, we can type the expression and then press enter. Now, we type this expression. Immediately after pressing enter, the computer will print 27 in the console. And that's what we are expecting. The computer has done a great job of evaluating the expression we gave. Now, move on to analyzing the definitions. We type them on our functional calculator. We have defined the two definitions, square and max. We can call the list of definitions script by calling the square function followed by any number representing variable a. We will be given the square of that number. Also, in the max definition, we serve two numbers to represent variables a and b, and then the computer will evaluate this expression to find out the biggest number between the variables. By defining these two definitions, we can use them as a function, which we can call session like this. The computer will definitely print 9 after evaluating this function. The computer will also be able to evaluate this function. It will return 2 as the result based on the definition we defined earlier. This is also possible if we provide this expression. Then, 25 will be displayed in our calculator console panel. We can also modify a definition using the previous definition. Suppose we want to quadruple an integer number and take advantage of the definition of the square function. Here is what we can send to our calculator. The first line of the preceding expression is a definition of the quad function. In the second line, we call that function, and we will be provided with 10,000 as the result. The script can define the variable value. For instance, take a look at this. So we should expect the computer to be able to evaluate this definition. Now moving on to using substitution and simplification to evaluate the expression. Use a mathematical method called reduction. We can evaluate expressions by substitution variables or expressions to simplify the expressions until no more substitution on reduction is possible. Let's take this expression, square, 1 plus 2, and look at the reduction process. First, we have this symbol to indicate the reduction. From the sequence, we can discover the reduction process. In other words, the evaluation process. In the first line, the computer will run 1 plus 2 expression and substitute it with 3 in order to reduce the expression. Then, it will reduce the expression in the second line by simplifying square 3 to 3 times 3 expressions. Lastly, it will simplify 3 times 3 and substitute it with 9, which is the result of that expression. Actually, an expression can have more than one possibility in the reduction. The preceding reduction process is one of the possibilities of a reduction process. We can also create other possibilities like this. In this sequence, firstly, we can see that the rule for a square is applied. The computer then substitutes 1 plus 2 in line 2 and line 3. Lastly, it multiplies the number in the expression. From these two examples, we can conclude that the expression can be evaluated using simple substitution and simplification, the basic rule of mathematics. We can also see that the expression is a representation of the value, not the value itself. However, the expression will be in the normal form if it can't be reduced anymore. Now, understanding the function used for functional programming. Functional programming uses a technique of emphasizing functions and their application instead of commands and their execution. Most values in functional programming are function values. Let's take a look at this mathematical notation. From this notation, we can say that function f is a relation of each element stated there, which is a and b. We call a the source type and b the target type. In other words, this notation of a and b states that a is an argument, where we have to input the value, and b is a return value or the output of the function evaluation. Consider that x denotes an element of a, and x plus 2 denotes an element of b. So we can create the mathematical notation like this. In mathematics, we use f of x to denote a functional application. In functional programming, the function will be passed as an argument and will return the result after the evaluation of the expression. We can construct many definitions for one and the same function. These two definitions are similar and will triple the input passed as an argument. As we can see, triple and triple apostrophic have different expressions. However, they are the same functions, so we can say that triple equal to triple apostrophic. Although we have many definitions to express one function, we will find that there is only one definition that will provide to be the most efficient in the procedure of evaluation, in the sense of the reducing the expression we discussed previously. Unfortunately, we cannot determine which one is the most efficient from our two definitions, since that depends on the characteristic of the evaluation mechanism. Moving on to forming the definition. We have this definition in order to retrieve the value from the case analysis. There are two expressions in this definition, distinguished by a Boolean value expression. The distinguisher is called guards, and we use them to evaluate the value of true or false. The first line is the one of the alternative result values for this function. It states that the return value will be a if the expression a greater than equal to b is true. In contrast, the function will return value b if the expression b greater than equal to a is true. Using these two cases, the max value depends on the value of a and b. The order of the case doesn't matter. We can also define the max function using the special word otherwise. You have to write otherwise after b. It ensures that the otherwise case will be executed if no expression results in a true value. Here we have refactored our max function using the word otherwise. Now, in this definition, we can see that if the first expression is false, the function will return b immediately without performing any evaluation. In other words, the otherwise case will always return true if all previous guards return false. Another special word usually used in mathematical notations is where. This word is used to set the local definition for the expression of the function. Let's take a look at this example. In this example, we have a function f with variable z, whose value is determined by x and y. There, we introduce a local z definition to the function. The local definition can also be used along with the case analysis we have discussed earlier. This is an example of the conjunction local definition with the case analysis. In this function, there is a local z definition, which qualifies for both x plus z and x minus z expressions. Although the function has two equal to signs, only one expression will return the value. Let's move on to currying. Currying is a simple technique of changing structure arguments by sequence. It will transform an n-array function into an unary function. It is a technique which was created to circumvent limitations of lambda functions, which are unary functions. Let's go back to our max function again and get this definition. We can see there is no bracket in the max a b function name. Also, there is no comma separated a and b in the function name. We can add a bracket and a comma to the function definition like this. At first glance, we find the two functions to be the same since they have the same expression. However, they are different because of their different types. The max apostrophic function has a single argument, which consists of a pair of numbers. This type of max apostrophic function can be written like this. On the other hand, the max function has two arguments. The type of this function can be written in this manner. The max function will take a number and then return a function from a single number to many numbers. From this max function, we pass the variable a to the max function, which returns a value. Then that value is compared to a variable b in order to find the maximum number. Lastly, let's go through a brief comparison between the functional and imperative programming. The main difference between functional and imperative programming is that imperative programming produces side effects while functional programming doesn't. In imperative programming, the expressions are evaluated and its resulting value is assigned to variables. So when we group series of expressions into a function, the resulting value depends upon the state of variables at that point in time. This is called side effects. Because of the continuous changes in state, the order of evaluation matters. In functional programming world, destructive assignment is forbidden, and each time an assessment happens, a new variable is induced. Cool! We got introduced to functional programming in this video. That's great! In the next video, we'll see preparing the C# compiler.